Good morning. This is your math sensei, Mr. Spensei, and this is STAAR review problems 1 through 10, and this is practice tests. So practice test problems 1 through 10. It says which expression is equivalent to 2m to the fourth times 5m to the eighth. So first off, if we didn't have the exponents, if it was just 2m times 5m, we'd go 2 times 5, and we'd get 10. And so right away, we should be able to eliminate ourselves, get rid of those, because we're just multiplying 2 times 5 and get 10. That's easy. Okay, what we may not know, and I don't consider it super important, but if you could eliminate two answers, you're down to 50% chance of guessing this right. But when you're multiplying, I know this is weird. When we're multiplying, we multiply the coefficients. So we went 2 times 5. We did that, and we got 10. But for the exponents, we don't when we say multiply, we actually add them. So 4 plus 8, and that gives us m to the 12th. So our answer to number 1 is B. Number 2, the function f of x. By the way, I see this and I go, oh, that's just y. So y equals x. Okay, so they're giving us a graph y equals x was transformed to form g of x equals f of x minus 23. Well, that's scary, but I know that f of x is just x. So that tells me g of x is equal to, hey, f of x is x. I can just substitute this x right here for that. So now that becomes x minus 23. Okay. Also, please remember g of x, that's just another way of saying y. So now we have y equals x minus 23, and you're like, I'm not sure this really helps. I have two equations. Well, I think it does. I think it's going to help because we can go look at Desmos, and that's what we're going to do first is we're going to look at Desmos and see what happens. And I'm going to input y equals x and y equals x minus 23. So I'm going to go to my share screen. And I have y equals x. And then I'm going to put in y equals x minus 23. It's like, it doesn't show. I can't see it. So hit the negative arrow and zoom out. Like, oh, I have two parallel lines. The first one, the original was red. The second one is blue. So what happened? Well, we ended up with parallel lines. They have the same slope. They never intersect. But the second one, because the red one was our original, the blue one shifted down, and it looks like it shifted down by 23, because this is at 0 and this is at 23. Okay, so that's what happened. We have two parallel lines, and it shifted down. So the first one, the graphs of f and g are not parallel. No, we know they are. Okay? Graphs of f and g are not parallel. Nope, that's false. We know they are. The graphs in g are parallel, and the graph of f is translated 23 units up. No, it wasn't translated 23 up. It was translated 23 down. So our answer to number 2 is D, because we had our original graph, and I'll try to draw it the way it showed up. It looked like this. This was the y equals x. And then we had the next graph, which was in blue, and that was y equals x minus 23. And so we went down 23. Okay, moving on to number 3. A graph of a quadratic function is shown. What are the x-intercepts of the function? They could have asked for the roots. They also could have asked for the zeros. They're all the same thing. So where did it cross at? And they just want us to, and they say x-intercepts. Well, guess what? That means, since it says x-intercepts, that means I need my x-axis. And just by doing that, I actually shaded my 2 points because this is 1 point and this is another point. If they'd asked for my roots, I would have said x equals -1 and x equals 3. Okay, that's number 3. Not too bad. Number 4, an artist bought a set of 10 paintbrushes that contain X small paintbrushes and Y large paintbrushes. I'm just going to tell you real quickly, that's confusing to me, but we'll keep going. The number of small paintbrushes in the set was 4 times the number of large paintbrushes. Which of the system of equations can be used to find the set of numbers, small paintbrushes and large paintbrushes? So let's talk about this. X is small. How about we do S equals small? And we'll make an X. We note that that's X. And L equals large. And these are paintbrushes. Now, you don't have to write all that stuff out. I would highly recommend writing L and S, but you don't have to sit there and say it's a paintbrush. Now, they told us that Y is the large. Okay? Well, an artist bought a set of 10 paintbrushes. So that means when we bought them, we had S, the small paintbrushes, plus the large paintbrushes, equals a total of 10, because this right here represents the total. Now, here's where, so we know it's going to be S plus L, but we said, oh, wait a second. That's X plus Y equals 10. Well, guess what? That gets rid of that one, and that gets rid of that one. If you can get the first equation, we're already down to 50%. We're already down to guessing. Now it says the number of small paintbrushes was is another word of saying is. Remember from English, was and is are be verbs, equals 4 times the number of large. So small equals 4L. Oh, but they didn't use that. They used X's. So in this case, we'll have to go X equals 4Y. Oh, X equals 4Y? Huh, that's not this one. Answer choice A. Okay? All right, a little bit of a trickier one. This looks so scary. This, just so you know, it's an exponential, and we don't talk a lot about them. But honestly, these are give me problems. They're not that difficult. So when I see this and I'm like, gosh, I don't know what to do, I'm gonna go, well, if I don't know what to do, and please remember f of x just says this is y. So really, this is y equals 3 2/3 raised to the x. Now, because this is less than 1, this tells me it's decay. And this is my start. So this is where I start. This is my decay because it's less than 1. Because it's less than 1, it's decaying. So that's what we need to know for other problems, not so much for this one. But when I see this, what do I do? Well, this is where I'm going to slip back over to Desmos, and I'm just going to put in that equation just like this. Okay? So here we go. Clear out the previous problem. And we have y equals 3 parenthesis 2 divided by 3. Oops. Wow, I'm messing all that up. That looks horrible. Y equals 3 parenthesis 2 divided by 3. And let's get rid of that. Close that parenthesis up. I'm going to go to my keyboard here, and I'm going to push this A-B button. Oh, I'm sorry. I can't see it. Now you can. Now, right here, I'm going to go to my keyboard, and I'm press the A-B button, and that gives me an exponent, and I'm going to press X. Hey, I got a graph. That's good. Now, what I notice is, first off, not that they asked, but I'm going to get closer and closer and closer to 0. So this right here never quite gets to 0, but it gets closer and closer. The y keeps getting closer and closer. So y equals 0 is an asymptote, but I cross at 0, 3. So I need to cross at 0, 3, and it needs to be downward. So with that in mind, let's look back at our paper. Well, these two are wrong because they're going the wrong direction. So now I have these two that are going in the right direction. By the way, these are decay because they're going down. And these are increasing. Okay, these are growing. So this is exponential growth. This is exponential decay. So we know this is less than 1, so it had to be decay. And I'm going to go flip back over because we need to determine, hey, is it crossing at 1 or is it crossing at 3? Well, 3 is my starting point. So guess what? That's where it crosses back. And I'm going to look back over to Desmos just to verify that I actually have the right solution. Well, I say I'm going to do that. I'm having trouble getting there. There we go. And when I hold over, yep, I cross at 3. That's my best answer. Okay. So there it is, crossing at 3. All right. Moving on to question number 6. For quadratic function f, the solutions to the equation f of x equals 0 are 7/5 and 2/3. Which function could represent f? Well, there's several ways to go about this, but they're telling us the x-intercepts, the roots are 7/5 and 2/3, and they want to know which one crosses there. So really what we have is 7, 5, comma 0, and negative 2/3, comma 0, because we know it's x and y. And you're like, gosh, I'm going to have to factor all of this out. And yeah, you could, and it's not bad. It's actually a good practice, but we don't have to. We can just plug these in to Desmos. And please remember, we can replace the f of x with just a y. So let's go ahead and do that. I'm going to plug these in and see if we can't come up with our answer. All right, so here we go. Clearing that out, we have y equals 14x squared plus 11x minus 15. And when I look, I'm going to go, okay, there are my zeros. Well, that's negative 1.5. And this is some weird number. Okay. Now, problem is, and I guess I should stop this share for just a moment. This only gives it to me as whole numbers. So I'm going to stop my share for just a moment. Oh, plus 11x minus 15. So I'm going to stop my share and we're going to come back because there's one thing I need to do. I need to turn these into decimals because that's what Desmos is going to make this look like. So what's 7 divided by 5? Oh, that's 1.4. So this becomes 1.4 comma 0. So I'm looking for 1.4 comma 0. And I'm looking for negative 2 divided by 3. And that's negative 6,666, negative 0.666. There went the devil, comma 0. So that's what I'm looking for on Desmos. So I'm going to go back to my Desmos now and see if that's what we got. All right, when I share the screen, I'm like, well, that's negative 1.5, and I needed negative 1.4, so that's not right. And I need a positive 1.4. This is wrong. So this one's wrong. So we know the first one's wrong. A can't be A. So then we go, okay, let's try B. And to speed this up, I'm just going to copy this down and then edit it. Thought I was going to copy it. There we go. So we have the next one, we have 15x squared. 15x squared minus 11x minus 14. Well, this one's in blue. In blue, hey, that one's at negative 2/3. So that part's good because we needed a negative 2/3. And the other one we needed was positive 1/4. So guess what? Our answer choice for number 6 is B because we ended up getting off Desmos the 1.4 and the negative 2/3 that we needed. All right. So that's number 6. Number 7, a store manager adjusts the price of an item each week. Um, that the item can go of an item each week that the item goes unsold. The price of the unsold item in dollars is after X weeks can be modeled by the exponential function this. So this was my starting price. So please don't forget, this is my start. This is Y. This is 0.9. And because it's less than 1, this is a decay. Okay? And X is the number of weeks. Okay, so the initial price, that's another word for saying start. So my start was 320, and we'll look at the graph in just a moment. And it decays, and we know it decays because it's less than 1. That means it decreases. All right, so here we go. We will come back to the decay part in a moment because that part's tricky, but I want to plug this in so that you can see what it looks like on the graph. So we're going to go back and we're going to go to the share. And we have y equals 320 parenthesis 0.90. And we go to the A to the B button, and we press X. And I don't see anything. Well, I need to put the zoom out. And I zoom out, and it's like, oh, we started at 320. So that was where we started. That's our initial. And we're going down. So we are decreasing. Okay, so that tells us that part. Now, the question is how much are we decreasing? This is where it gets tricky. You want to go this. I know that's what because you see 90%, but please remember you have to do 1 minus whatever the decay is. So 1 minus 0.9, because it's always 1 minus the decay. All right? If it's an increase, it's going to be 1 plus the increase. Okay? But 1 minus the decay. So if we do this, we have 1 minus 0.9 and we get 10%. So our answer is these. So we have B for 320, B for decrease, and we have A for 10%. And that 10% part is a little bit tricky. Okay, number 8. Which expression is equivalent to the square root of 75? All right, I can go through all the math to explain it, and we can learn how to do this, but we have Desmos, and we're going to use Desmos because it'll be much faster than having to learn all the math behind it. So we have the square root of 75, so I'm going to go to my share button. We're going to share this, and we're going to put in the square root of 75. So I press the square root button, and I type 75, and I get 8.6602. So I'm going to write down 8.6602 on my paper, and I'm going to stop there at 4 places. Then I'm going to try, okay, what about 5 square roots of 3? Is that it? 5. Then I put a 3. Hey, I got the same answer. So in this case, we know that it's 8.6602. Our answer choice is A. But just to show you that this works, I'm going to do the next one. So 15 square roots of 5. And we get 33. That's not the right answer. The only one that could be is B. There's only one, is A. So the answer to number 8 is A, because for both of them, when we plugged it into Desmos, we got 8.6602. All right, number 9. A fish tank is being drained at a constant rate. The graph shows the linear relationship between the volume and model. It's important to note this says linear because that gives us a bunch of information. All right. Which value best represents the rate of change? Rate of change is slope. So there's several ways I could go about doing this. Now, for me, if I'm not sure on what to do, I think one of the easiest things is to make a table and find 2 points where it crosses perfectly. Well, at 0 and 60, it crosses perfectly. That's 1 point. And it looks like it crosses perfectly at 10 and 0. Please remember, pay attention. This is my x, this is my y. So when x is 0, y is 60. When x is 10, y is 0. So that's what we have. Now they told us it was linear up here, and that's really important because that allows us to know what to do. So with that in mind, I'm going to go to Desmos and I'm going to make a table and input this in the table. So we're going to press the share button. All right, I don't see table. Where do I get table? Oh, plus button, table. And I said 0 and 60. And then we're going to do 10 and 0. Great. I don't have anything. I'm going to press the domino. The first one that pops up is linear. There's several there, quadratic and exponential. We use the quadratic and exponential, but right now they told us it was linear, so this is what we want. So there's my equation. Y equals negative 6x plus 60. And I'm going to write that down on my paper. Y equals negative 6x plus 60. And now we're going to look back at my paper and figure out what we can do. Like, great, we got this equation. What does it mean? Well, this is in y equals mx plus b format, and m is my slope, b is the y-intercept. All right, well, b is 60, and m, which is what we care about, was, oh, it was a negative 6. So my slope is negative 6, and by the way, just by guessing, we knew we were going down because we have a downward trend, so it had to be negative. So I got rid of those two right away. Okay, this is the last problem for this video. It's number 10. It says, what is the solution set for 12 minus 4w is greater than 2w minus 18? This is one of the more difficult problems to do. But first off, we need to change this around. We're going to have to go 12 minus 4n squiggle. If you see the squiggle, you should know that I'm taking this to Desmos. That's what we're going to do. And we're going to get some value. Okay? All right. And by the way, I see a negative there. If I see a negative, that means I need to switch the signs. So this sign is going to flip directions because this is negative in front of the variable. Because if it's negative in front of the letter, if it's negative in front of the variable on the left, we're going to switch the signs. So since I'm switching the signs, okay, since I'm switching the signs, this is going to switch directions. That gets rid of this problem, and that gets rid of this one. So it can only be B or C, or at least that's what we think. So let's see what happens. We're going to drop over to Desmos and see if we can't figure out our answer. Get all this hard work that we did out of there. And I'm going to type in 12 minus 4n squiggle 2 parenthesis n. we get 8. So my answer there is n equals 8. We see that right there. So let's go back. And once again, it's like, okay, these are my 8s, but I already crossed this one out because we think this is going the wrong direction because this was a negative in front of the variable. So my best answer, we know it can't be 5. So it must be letter C. All right. Um, just because the way these works out, I'm going to go ahead and do um, um, problem 11 since it breaks out nicely onto this page. So problem 11, what are two factors of 2x squared plus x minus 15? So I'm going to do this the long way, and then I'm going to show you what you can do on Desmos. So in the long way, I go, well, I have to multiply across, and this becomes x squared plus x minus 30. So I need the factors of 30. Always with the large factors on the left. So this will always be a. So we're going to go y equals 30 divided by x, blue graph, and we have 30 and 1, 15 and 2, 10 and 3, and 6 and 5. Because this is a positive, I know these have to be positive, right? Because we always pay attention to the middle term. Now this is like having a positive 1 there, okay? So I'm going to make my triangle, and I have a positive and a negative, which means these have to be negative, and I have to end up with a positive 1. Well, that gives it to me. So this is going to be x plus 6 times x minus 5. But we multiplied by 2 at the beginning, so I have to come back and divide by 2 at the end. So this becomes x plus 3. This does not divide, so it slides to the front and becomes 2x minus 5. Well, right there, we see that our answers are going to be x plus 3 and 2x minus 5. That's one way to do it. That's a great way of doing it. That's the way I hope you can do it for Algebra 2 and geometry and actually for Algebra 1. But let's see what we can do with Desmos to see if that problem scares you. So with Get Desmos, going to our Desmos screen, I'm going to input that 2x plus, I'm going to put in the original equation. The original equation was 2x squared plus 1x minus 15. And by the way, you know what? I don't even have to put that 1 in there. So let's take that out. Okay. Now, I'm going to need to zoom in a bit. And where do I cross? I crossed at 2.5 and I crossed at negative 30. That's what we found. So I'm going to write down those values. I'm going to write down negative 30 and 2.5. And 2.50. Negative 30, you see that? And 2.50. Okay, so I'm going to stop the share. That's where we crossed. And all we really care about are these values here. Now, here's the thing. Factors, you have to switch the sign. These are the liars. All right, so I need, let's tell, oh, the opposite of negative 3, positive 3. That's what we have there. So that takes care of this one. This one's a little trickier. All right, 2.5. And so, but I know I have to switch it. So I need gonna have to have a negative. So that gets rid of this and it gets rid of this. The one with the negative 5 is this. And let's try it out. Let's set 2x point, let's say 2x minus 5 equals 0. Add 5 to both sides. I had 2x equals 5, divide by 2, x equals 5 halves. So guess what? What's 5 divided by 2? Oh, that's 2.5. So once again, that supports it. Number 11, kind of tough. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.